Good evening, dear friends. Today I will discuss some problems of Laplace transform as well as inverse Laplace transform of some functions. Okay, so let us start. So first question is, what is Laplace of t to the power n? So by definition, we know that Laplace of t to the power n is integration from 0 to infinity e to the power minus st and into t to the power n dt. So to solve this, we have to know something that is about the gamma function. So from the gamma function we know the definition. What is gamma function? Gamma of n is equal to integration from 0 to infinity e to the power minus x to the power n minus 1 into dx. And from this definition we know that gamma n plus 1 is equal to n into gamma of n, and gamma n plus 1 is equal to n factorial when n is a positive integer. So when n is positive integer, the value of gamma n plus 1 will be n factorial. Otherwise, gamma n plus 1 is generally n into gamma of n. So they are the property of a gamma function. So now we have to use this gamma function to find out the value of this integral. So to solve this, put st equal to x. Suppose st equal to x, then what will be the value of t? So t will be x by s, and that implies what? dt equal to dx by s. And now since the limit of t here it is 0 to infinity, so that's why we have to change the variable x, so that we have to find the limit of x also. So that's why when t equal to 0, then the value of x will be also 0. Fine. Similarly, when t tends to infinity, the value will be also x tends to infinity. Is not it? So the integral reduces to what? 0 to infinity e to the power, in place of st put x, because st equal to x, so e to the power minus x. Then the value of t means x by s, so x by s whole to the power n into, in place of dt it is dx by s. So we got what? E to the power minus x, x to the power s whole to the power n into dx by s. Now we have to integrate with respect to x. So we have to consider what? S as constant. We know it. So it will be x to the power n, and here what s is there. So 1 by s to the power n plus 1, integration from 0 to infinity, and it is e to the power minus x, x to the power n into dx. Fine. So by the definition of gamma function, we know that gamma n equal to e to the power minus x, x to the power n minus 1 dx, integration from 0 to infinity. So if you compare with this integral, then e to the power minus x, e to the power minus x is there. Here x to the power n minus 1, but here it is x to the power n. So when it is x to the power n minus 1, then the value will be gamma n. But here we have x to the power n. So what will be the value? What will be the value? It will be gamma n plus 1. It is gamma n plus 1. So the value will be, the final value, what is the final result? Gamma n plus 1 divided by s to the power n plus 1. Okay. So what we got here? Laplace of t to the power n, we can write gamma n plus 1 divided by s to the power n plus 1. Fine. Understood? Okay. So in the previous example, what we got? Laplace of t to the power n is equal to gamma n plus 1 by s to the power n plus 1, and from the formula of gamma function, what is the property of gamma function? We know that it is n gamma n divided by s to the power n plus 1, because gamma n plus 1 is n gamma n. Okay. So you can note here that when it is means n is a positive integer, then what will be the value of Laplace of t to the power n? It will be n factorial by s to the power n plus 1. Why? Because gamma n plus 1 will be n factorial. Already we wrote, so gamma n plus 1 is n factorial when it is positive integer. So that's why Laplace of t to the power n will be n factorial by s to the power n plus 1 when it is an positive integer. So using this formula we can solve this type of problems, simple problems, very simple problems. Directly you can use the formula, that is what is Laplace of t. So what is Laplace of t? Because here it is 1 factorial by s to the power 1 plus 1 according to the formula, because t to the power 1, so t to the power 1 means it's positive integer, so it is 1 factorial by s to the power 1 plus 1, and that is 1 by s square, simple. Similarly, Laplace of t square is 2 factorial by s to the power 2 plus 1 using this formula, so 2 by s cube. Similarly, Laplace of 5t cube, 5t cube means 5 using linearity principle, already we discussed in a previous lecture. So we can take out that 5, so 5 Laplace of t cube, is not it? Laplace of t cube. So according to the formula, it is 3 factorial by s to the power 3 plus 1. So 5 into 3 factorial divided by s to the power 4. So these are the Laplace transform of this function. And if you want to find the inverse of this, the resulting functions, inverse of this resulting function, we must get these functions, the original function. So how? Because Laplace of f of t equal to f of s. If Laplace of f of t equal to f of s, then what will be f of t? It is Laplace inverse of f of s, in inverse function we discussed. So what will be Laplace inverse of 1 by s? Because Laplace of 1, we know that Laplace of 1 is 1 by s. In the first lecture we discussed Laplace of 1 is 1 by s. Laplace of 1 is 1 by s. We know that. Okay, so Laplace of 1 is 1 by s. So that's why Laplace inverse of 1 by s is equal to 1, because you take this. So Laplace inverse of 1 by s equal to 1. Similarly, in the first example, Laplace of t equal to 1 by s square. So that means Laplace inverse of 1 by s square will be t, the original function. Similarly, Laplace inverse of 2 by s cube, because Laplace of t square equal to 2 by s cube. So Laplace inverse of 2 by s cube will be what? T square. That is equal to t square. Similarly, Laplace inverse of 3 factorial by s to the power 4. So what is the formula? Whose formula is this? Whose Laplace transform is this? Basically, we have to find whose transform of this, whose transform is 3 factorial by s to the power 4. Okay, so what is the answer? T cube. So Laplace of t cube is 3 factorial by s to the power 4. So that's why Laplace inverse of 3 factorial by s to the power 4 will be equal to t cube. Got my point? Okay. Next. So what is Laplace of t to the power half? So by the formula we have Laplace of t to the power n is gamma n plus 1 by s to the power n plus 1, right? And that is n gamma n by s to the power n plus 1. So Laplace of t to the power half means here half is not a positive integer, it's not integer. So that's why we can put this formula. Okay, it is not factorial. So so t to the half means it will be half gamma, half n gamma n. So it is n plus 1 means half plus 1, and according to this formula it is half gamma half, and s to the power n plus 1, so s to the power half plus 1, s to the power 3 by 2. So half gamma half s to the power 3 by 2. Understood? Now half, and what is the value of gamma half? What is the value of gamma half? It is root 5. So half root 5, then s to the power 3 by 2, right? So root 5 and 2 into s to the power 3 by 2. So Laplace of t to the power half is equal to root 5 divided by 2 into s to the power 3 by 2, right? Similarly, you can find Laplace of t to the power 3 by 2 also. Same procedure. That is Laplace of, since it is not integer, it's a positive but not integer. So gamma, according to this formula, gamma 3 by 2 plus 1 divided by h to the power 3 by 2 plus 1. So according to this formula, n gamma n, so 3 by 2 plus 1 means 3 by 2 gamma 3 by 2, h to the power 3 by 2 plus 1, so it is 5 by 2. So 3 by 2 gamma 3 by 2 h to the power 5 by 2. Now again gamma 3 by 2 we can break it like gamma half plus 1, means we can write 3 by 2 as half plus 1, it is 3 by 2. So 3 by 2 into, according to again this formula n gamma n, so half plus 1 means it will be half gamma half. So 3 by 2 into half gamma half, h to the power 5 by 2. So it will be what? 3 into 1, then gamma half, the value of gamma half is root 5. So it is root 5, 3 into 1, then 2 into 2 is 2, 2. So 2 into 2, 4, h to the power 5 by 2. So the result is 3 root 5, 4 into h to the power 5 by 2. Clear? Again, next example, Laplace inverse of 1 by h to the power s minus 5. Laplace inverse, what is Laplace inverse of 1 by s minus 5? 1 divided by s minus 5. So we know that, what is the formula? Laplace of e to the power at. What is Laplace of e to the power at? Is equal to 1 by s minus a. This is the formula. Already we have derived. Laplace of e to the power at is equal to 1 by s minus a. So if I take its inverse, so Laplace inverse of 1 by s minus a will be e to the power at. Is not it? So this is in that form, 1 by s minus a, 1 by s minus 5, s minus 5, so a is 5. What is a? A is 5, right? So 1 by s minus 5, Laplace inverse of 1 by s minus 5 will be e to the power 5t, e to the power 80, so e to the power 5t, a is here 5. Similarly, again Laplace inverse of, what is Laplace inverse of s divided by a square plus 4, s divided by a square plus 4. So to find this, we have to remember the formula. What is the formula? Laplace of cos at. What is Laplace of cos at? Is equal to s by a square plus a square. Now if you compare with this formula, s by a square plus 4, s by a square plus 4. So what is 4? A square equal to 4. So what is a? A is equal to 2. You can write this 4 as 2 square. 2 square. So a square plus 2 square. So a is what? Or a is 2. So the value will be cos 80. Inverse of will be cos 80. So the answer is cos 2t. So Laplace inverse of s divided by a square plus 4 is equal to cos 2t. Clear? Or is there any problem? Okay. Here we can note that inverse Laplace transform is a linear operation. In the previous case we tested, means we have already proved that Laplace transform is a linear operation. Similarly, inverse Laplace transform is also a linear operation. We can prove this also. We can prove this. What is the proof? Suppose we have two functions, f of t and g of t, and Laplace of f of t, suppose f of s, and suppose Laplace of g of t equal to g of s. Okay, so if Laplace of f of t equal to f of s, then what will be your original function small f of t? F of t will be Laplace inverse of f of s. Similarly, since Laplace of g of t is equal to g of s, so g of t will be Laplace inverse of gs, right? So now we have to check, since it is we have to check what is it's a linear operation. So consider Laplace of a f t plus b g t, Laplace of a f t plus b into g of t. So according to linearity principle of Laplace transform, we can write like a into Laplace of f of t plus b into Laplace of g of t, right? Because it's a linear operation. Now a, that is equal to a Laplace of f of t equal to f of s, we considered, that is f of s plus b into Laplace of g of t mane g of s. So we got what? A of s plus b into g of s. Now since Laplace of this function equal to a of s plus b of into g of s, so we can write like Laplace inverse of a f bgs. Laplace inverse of this function will be a f t plus bgt. Is not it? So Laplace inverse of a f s plus bgs equal to a into f of t plus b into g of t. Now a into f of t mane, what is f of t? Because f of t equal to Laplace inverse of f of s, we can write Laplace inverse of f of s plus b into Laplace inverse of, in place of g of t, it can be written as Laplace inverse of gs. So what we got? Laplace inverse of a f s plus bgs is equal to a into Laplace inverse of fs plus b into Laplace inverse of gs. So that's why we can write inverse Laplace transform is also a linear operations. Linearly you can operate the linear inverse Laplace transform as your Laplace transform. Okay, so okay, we will meet in the next lecture, and again we will discuss some more complicated problems, more critical problems of Laplace transform. And thank you for today. And if you like this video, then try to subscribe. Thank you all.